Alright everybody, welcome back to psychology. In this chapter we're going to be taking a look at some research methods. So why do we look at research methods in psychology? Well, it's easy to be deceived by statistics and percentages, and you should always know the sample size, know the specifics of the research, think critically about the results being communicated, ask questions about the research, and search for evidence both supporting and disproving the research. So we get into intuition. Well, what's intuition? Intuition is a gut feeling or instinct. We can't rely on just intuition when making decisions because of hindsight bias and overconfidence. Recall from the previous video that empiricism is an approach to research that relies on sensations and experiences and observations for data. Researching answers to psychological questions using systematic observations withholds judgment and searches for objective evidence based on valid and reproducible studies. All psychological research methods attempt to answer psychological questions empirically, but different strategies are used to investigate different behaviors. Regarding the scientific method, psychologists use the scientific method to test their ideas empirically, and the scientific method consists of developing a hypothesis, performing a controlled test, gathering objective data, analyzing the results, and publishing, discussing, and replicating the results. There are 6 main ways to collect data for psychological research: direct observation, which is watching and recording behavior; a questionnaire, which is giving written questions to get information on attitudes and opinions; an interview, which is having a face-to-face dialogue to get specific information about behavior; a psychological test, which is a standardized test to assess abilities or personality traits; a physiological recording, which measures a physiological process such as blood pressure or heart rate, and examining archival records such as censuses, economic information, etc. So the hindsight bias I mentioned earlier, I just wanted to get a little bit more into that. The hindsight bias is the phenomenon where once a person learns the outcome of an event or situation, they have a tendency to believe they could have predicted it. This bias is a reason for rigorously scientific psychological research. The hindsight bias occurs everywhere across the globe. It's not limited to one culture or one area of the world. It's worldwide. And an example, a pretty famous example you see of hindsight bias is after 9/11. You have a lot of people saying Americans should have seen it coming and things like this. That's a great example of the hindsight bias because you couldn't have necessarily predicted it, but after the events happen and you look at all the evidence and all the things leading up to it, and you say that Americans should have predicted it. So overconfidence is something I also mentioned earlier. Overconfidence is the phenomenon where a person believes they know the outcome of an experiment before the experiment is performed. This prevents the research from taking all factors into consideration. People tend to be more overconfident than they are correct, and hindsight bias can worsen overconfidence. Applied research is done in order to apply psychology in practical situations. Applied research is used to fix or remedy issues, and applied research also involves working with patients. Basic research aims to build knowledge by gathering information about the growth of psychology. This focuses on why a behavior occurs. Then you get into types of studies. You get into longitudinal studies, which are a study of a group of people over a long period of time. And a way you can remember that is like longitudinal has the word long in it. So longitudinal studies may not always be viable because they can be long, expensive, and participants can drop out of the study at any time. Patients must also be tracked down, which can create difficulties, and longitudinal studies are used in both basic and applied research. Then you get into cross-sectional studies, which makes comparisons between specific age groups or specific groups. So an example of a longitudinal study is studying how smoking affects the lungs over a lifetime, whereas a cross-sectional study could be how the different genders play on the playground during recess. Then you get into another type of study, which is a descriptive study. These describe behavior, but they're not used to find an explanation for why a behavior occurs. So for your descriptive studies, you have surveys, case studies, and naturalistic observation. Surveys are given to large groups in order to get various opinions quickly. Surveys can be misleading because of the wording effect, which is when a researcher writes questions using connotative or emotionally charged language. Then there's the false consensus effect, which is when a researcher believes that their subject will agree with them on an issue, causing the questions to be written to support or disapprove of the opinion. And then there's the social desirability effect, which is when subjects answer in a way that makes them look good. So for case studies, it's when you're studying a single or several unique individuals. Sigmund Freud pioneered the idea of the case study with his psychoanalysis, and then these are very useful for extensive examination of a person or issue. And the downside of case studies is that one person does not necessarily represent the general population. Then you get into naturalistic observation, which is where observing a subject and it's where you observe the subject in its natural environment. This method is reliable only if the subject does not know that they are being observed, and once the subject knows they are being observed, they will stop behaving naturally. So descriptive statistics are used to organize and summarize data and consist of measures of central tendency, measures of variability, and the coefficient of correlation. So for your measures of central tendency, you have the median, which is the score that it falls in the center of the distribution, the mean, which is the average of the scores in the distribution, and the mode, which is the most frequent score in the distribution. Generally speaking, the mean is the most useful. However, extreme scores can skew the mean. If extreme scores are present in your data, it's better to use the median. And at the bottom there, I've included a little like a mnemonic device to help you remember these three things. So variability. Variability refers to how much the scores in a data set vary from one another and from the mean. Standard deviation is the amount of variability in a data set. The higher the variability, the larger the standard deviation, and the lower the variability, the smaller the standard deviation. Now we get into a new type of study, which is the correlational studies. These examine the relationships and make predictions between variables. Studies showing that alcoholism increases the likelihood of a fatty liver, for example, are correlational. But it's important to remember correlation does not prove causation. Correlational studies just observe a relationship. They do not confirm or deny a cause. Because of this, when publishing correlational research, refrain from saying X causes Y or this thing causes that thing. Instead say this thing increases the likelihood of that thing. So here's some examples of correlation not proving causation. A really infamous one you see is the divorce rate in Maine goes down as the per capita consumption of margarine in the US goes down. But that doesn't mean that lower divorce rates in Maine has caused everybody in the US to eat less margarine, and it doesn't mean vice versa either. They just correlate. So when can we say that a correlation between two variables exists? That we can say when two variables are related to each other. And to determine if two variables are related to each other, we have to look at the correlation coefficient. The correlation coefficient is the statistical measurement of the degree of relationship between two variables. The correlation coefficient indicates the direction of the relationship, be it positive or negative, how strongly the variables are related, and the closer the correlation coefficient is to +1 or -1, the stronger the relationship. So it doesn't have anything to do with the plus or minus sign, it just is how close it is to like +1 or -1. So a correlation coefficient of -0.98 is stronger than a correlation coefficient of 0.5, for example. Okay, scatter plots. Scatter plots are used to display data from a correlational study. A positive correlation coefficient represents a positive relationship. A negative correlation coefficient represents a negative relationship. A correlation coefficient of 0 represents no relationship. So, what does a positive correlation mean? It means that two variables vary in the same direction. So the more of one thing, the more of the other thing. and a negative correlation means they vary in opposite directions. So the more of one thing, the less of the other thing. Illusory correlations occur when a researcher believes that there's a relationship, but in reality there is no relationship. This is usually a byproduct of a researcher wanting to prove their own hypothesis. Inferential statistics are used to interpret data and draw conclusions. Then we get into statistical significance, which means if the correlations drawn by research are statistically significant, it means that the results are not likely due to chance. Statistical significance is determined by the p-value. If the p-value is less than 0.05 or 5%, the results of the research are statistically significant. Experimental studies are another type of psychological studies. These studies establish cause and effect relationships among variables due to the researcher changing a variable and then observing the effects on another variable. The steps to experimental studies consist of making a theory, forming a hypothesis, getting a sample population, creating operational definitions, and controlling for confounding variables. So, a theory is a general explanation that makes predictions or observations. A hypothesis is a testable prediction derived from a theory. Sampling is the act of choosing a person or people to act as a representative of the population you're trying to study. Random sampling means each person in the population has an equal chance of being chosen to participate as everyone else in the population. This ensures the highest chance of accurate representation. Another important thing to consider in an experiment is finding the population. A population is the specific group which will be used for the study. A representative sample is a sample taken from the population. They're meant to represent the population. You're also going to want to make operational definitions. Operational definitions are precise definitions on how each variable will be used in the experiment. The point of operational definitions is for other researchers to be able to replicate the experiment. So let's say you're doing some sociological research on why we laugh. An operational definition for this experiment might be what will be considered a laugh in this experiment. You're also going to want to consider variables. The variable is the characteristic that will be manipulated or measured. There will be an independent variable and a dependent variable. The independent variable is the variable that is manipulated by the researcher, and it's the variable that the researcher is attempting to study. The dependent variable is the variable that shows the outcome. Another variable you're going to want to consider is a confounding variable. These are variables that could affect the outcome of the dependent variable that were not controlled for by the experimenter. You see a lot of confounding variables in educational psychology research when they're testing, does this method of studying result in higher test scores than this other method of studying or not studying at all. And the confounding variable there is that the people taking the test might just be more intelligent. So that's why the test scores in one group might be higher than the test scores in another group, because one group just might be more intelligent than the other, and you can't really control for that. So you're also going to have an experimental and a control group in an experiment. The experimental group is the group that receives the independent variable, and these are the people being given the change. So in the example I was giving with the new method of studying, the experimental group would be the group that's doing the new method of studying. And the control group is the group that does not receive the independent variable. They're compared with the experimental group to show how much change actually occurred. So the control group might either be told to not study or study in a traditional way that can show how much change occurs between the traditional method of studying and this new experimental method. Another important part of experiments is random assignment. This is the process of giving test subjects an equal chance of being chosen either for the experimental or the control group. This is important for ensuring, once again, a representative sample and lowers the chance that your results are due to chance or due to some interference from the researcher. You're also going to want to know the normal curve. You're going to want to know what it looks like and the different percentages. So one standard deviation, which means either from 0 to 1 or from 0 to -1, has 34.1% of the population. So, let's say, for example, this normal curve is the distribution of test results. That means most of the people taking the test will score near the middle of the normal curve. That's why there's so much data there. 34.1% falls between 0 and 1 standard deviation, or plus or minus 1 standard deviation is what you would say. And if you go from -1 to +1, then that's going to be 68.2%. And the normal curve is basically just trying to show that most people in well-done research will fall towards the average score, the middle score, I suppose. I think that's the best way to put it. I'm not really an expert on normal curves. There are probably a lot of other helpful videos up there, but normal curves is definitely not my forte. And for this class, all you need to do is just memorize the percentages. So there are a number of things that can mess up research, including sampling bias, placebo effect, experimenter bias, response set, and the halo effect. A sampling bias is when the sample is not representative of the population. The placebo effect is when participant expectations result in some sort of experience even though they receive a fake or ineffective treatment. A lot of times you'll see placebos mentioned with usually new medicine research, new medicine experiments. They'll give the experiment group the medicine that's supposed to treat some ailment, and then the control group will usually get a sugar pill. And they're told that it's the real thing because they're not supposed to know which group they're in. So they'll usually get a sugar pill, and if they experience a placebo effect, they might claim that their symptoms are being reduced or that their ailment is going away. In reality, they're experiencing the placebo effect. They're expecting that they're in the experimental group, and this results in some sort of false experience. Experimenter bias is when a researcher's expectations about the outcome of an experiment influence the results. We combat experimental bias by either a single-blind study or optimally a double-blind study. A single-blind study is a study in which participants don't know if they're in the control or the experimenter group. The researcher knows who's in the group though. In a double-blind study, neither the participants nor the researchers know who's in the group. And this is the most effective method because it counteracts the hindsight bias, the confirmation bias, and illusory correlations. Response set is the tendency to respond to questions in a way that is unrelated to what was asked. So this is usually where you answer true to everything, false to everything, or very much disagree, or very much agree to everything. Just answering in a way that you kind of contradict yourself by just answering the same way for each question. The halo effect is when a person's overall evaluation of another thing influences more specific ratings. And that's it for this one. See you next time.